Hello everyone. Welcome back again to this series of linked list. In this video lecture, what we are going to start with creating a linked list, right? So, here in this lecture, we are going to create a linked list, right? Let me just quickly revise that what is a linked list. Linked list is a collection of nodes which each node contains two parts. The first part is info part and the second part is link part. In my previous video, I already explained you what is a linked list, types of linked list, that singly linked list, doubly linked list, circular linked list. So all those stuff I have already explained, right? So we are going to start with a basic linear linked list. This collection of node where this links to the address of the next node, right? Again, I have one more node. This points to the address of the next node, and if this is my last node, so the address part would be null. And we have one pointer called head, and this head holds the address of the first node, because as you can see here that the second node's address is available here, right? This third node's address is available here. It does not contain any link further, no node is available, right? It's a null. But what about the first node, the starting node? So the address of this first node, that is stored in head. So this is address of first node, right? So this pointer points to head, is a pointer that points to this location, right? Now we are thinking of creating a linked list. That means I have nothing, right? I don't have any linked list, right? And I need to start with a scratch, that I want to have one linked list. So we'll start with it. So the first step is we need to initialize this head pointer, right, with the null value, right? Because we don't have right now any value, right? So we just initialize the header, right? So that means the head pointer. So simply I'm giving the value, I'm initializing head with the null value, right? Now this linked list go with dynamic memory allocation, right? We don't have static memory allocation in linked list. At runtime execution time, we allocate the memory, right? So it's not like an array that we need to predefine it and then we can go for it. No. So each and every time with the execution, we need address allocation, right? So I'm just creating a new node. So second step is create a new node, right? Using malloc or calloc, whatever you are comfortable with, and I'm storing its address, right? So store the address and pointer that is called new node, right? So new node, you can take any name, this is like my naming convention, right? So I'm taking new node, and this new node is a pointer, that means it stores the address of my newly created node, right? So this is address of new node, right? That means here I'll explain you that till now I have nothing, right? What I did, I have created one head and its value is null, right? So I'll simply write it, that is equal to null. Then I created one node using malloc, right? And its address, I have stored its address in new node, right? I have stored its address in new node, right? Now then what I need to do, step 3, that I need to add some value to this, because I have created a blank node, right? Now it have two parts, as I told you earlier, info and link part, right? So info part stores the information and link part stores the address of the next node, right? So here I'm just, what I'm doing, like I'm copying the information, that means the data, right, for the new node in info part, right? So in info part I'm storing this, right? So info of new node, that is equal to element. User can enter the element and you can directly store it over here, right? So after this, what I'm having, suppose that element is 5, so 5 is stored over here, right? Now next, what, info part is done, next is link part, right? So here I am having this only one element, no further node is only one node, no further node is connected to it. So as you can see that the last node is having the null value as my link, right? So for this also, what I need to do, that here I'm just set the link part as null. Why null? Because this is my one and only node, right? So I'm just storing link part as link of new node, that is equal to null, right? So that means here you have this null. So now my node is ready with the info part and the link part, but still it is like a node only, separate node only, because it does not connect to any other linked list or a new linked list, so it should be connected to head, right? So the step 5, what I need to do in the step 5, that I need to assign my head. Head is what? That is address of first node, right? So that is available in my new node, because here you can say new node is equal to address of new node. So that is available to new node and I need to assign it to head, right? So here I just need to check, but there is a condition, that if this new node is the first node, then what you need to do is simply you can assign head is equal to new node, right? Why? Because this new node is also address, this head is also address, right? And you are assigning the address, this new node, this I am assigning to head. Here instead of null it would be new node. So now I can say that my head is pointing to this, right? So as you can see here, I have a linked list now with only one node, right? So this is like your if condition, right? Then step, actually not step 6, that else part is remaining, that else means what, that if we are already having a linked list, as of now scenario, that I am already having a list, right, with one node. So after following that step 2 3 4, like this step, right, not step 1, because step 1 is for the first node only, right? But after following this, suppose I have this node ready with the link part and some node info part and some node part. So I need to like assign this, connect this to, right? So instead of this null part, it should point to this second node, right? So and thus I have the first a portion, that I should take the current pointer is just one pointer I am taking, right? I'll explain this traverser in my next video as well. So I'm just taking the current pointer to the last node, right? So here we are assuming that my current pointer, this how to take this current pointer to the last node, that is a part of a traverser. I'll explain this in my further videos. So current pointer is equal to address of last node. As of now we are directly assuming it. For this we need to apply the traverser, right? And if so, then what I need to do, this link of current pointer that I need to assign to this new node, right? So simply link of current pointer, because previously it was null, and this I am assigning to my newly created node, and the newly, as per this newly created node's address is available in new node, right? So that I am assigning to link of current pointer, right? So this is it, right? And if I go for step 6, that is exit or return, right? So this is very basic algorithm of creating a linked list, right? What we did, let me just quickly summarize, that first we initialize head with null value because we don't have any linked list. Then we created one node, right, that is a blank node using a calloc or malloc, whatever you want, right? And that address I have stored it in a pointer called new node, right? Then in the info part of new node I have assigned the element, and in the link part of new node I have assigned null because that is my node, right? And after that I don't have any other node, so that link part should be null. Then if the new node is the first node, that means I don't have any linked list, then simply I need to assign head is equal to new node, right? But if there is already one node is available, 1 2 3, any number of node is available, then what we need to do, that we need to take one current pointer, right? And as of now we are assuming that current pointer is equal to address of the last node, but we need to manually do it using a traverser, and then link of current pointer is equal to new node, and that's it. Yes, your linked list is created, right? So yeah, I hope you understood this. After this we'll have like traversing algorithm in my further videos. I'll explain you the insertion, the 3 type of insertion: insertion at the beginning, insertion at the end, insertion at the specific position, as well as deletion from the beginning, deletion from the end, and deletion from the specific position, right? So yeah, thank you so much. Thank you for watching this video. Thank you.